Welcome back, everybody. Today we are going to talk about writing linear equations. Okay, we'll start with this little warm-up. It's about slope. A highway has a grade of 7%. Okay, now percent means per 100. So that really means the grade of this highway is 7 per 100. Okay, and what that grade really means is the slope. The slope of the highway is 7/100ths. Okay, so that means that for every 7 feet the road rises, it goes 100 feet horizontally. Okay, so think of it as you're driving. You drive 100 feet forward, you've risen 7. Okay, now that doesn't really necessarily sound very steep, but it is steep enough in a road that, especially if you're going downward, if you're on the downside of that, you're going to have warning signs like this that tell you you've got a 7% grade. You may even see off to the side that there's this runaway truck ramp in case a truck loses control, which is really easy to do as you go downhill at 70 miles an hour for a while. So they can pull off to the side and stop safely. Okay, so that 7% grade, you're talking about a pretty steep highway. But the question is, for each 200 feet that the highway goes horizontally, how many feet does it rise? Well, if it rises 7 for every 100 feet, then by the time it's gone 200 feet, it's done twice that, so it has risen 14 feet. Okay, now into using slopes for linear equations. But first, let's talk about the types of equations or the forms of a linear equation. Slope-intercept form, y equals mx plus b, where b or m is the slope and b is the y-intercept. Then there's standard form. Standard form is ax plus by equals c. A or c can be 0, but they can't both be 0, because then you would have 0 equals some other number. Okay, or you'd have 0 equals 0, and that doesn't make anything. Okay, and then there's point slope form, and point slope form is y minus y1 equals m times x minus x1. Okay, so all three of these have their place. They're important forms of a line. So we're going to write an equation for this line, and we're going to write it in slope-intercept form. So in order to do that, I need to know the slope, and I need to know the y-intercept. So for the slope, here's what I'll do. I've got a point here, and I've got a point here. I'm going to connect them with a triangle. Okay, so I know that I'm falling from left to right, so I've got a negative slope, and it's falling 1, 2, 3, 4, 5, 6, and then it's running 1, 2, 3. So negative 6 over 3, which is the same as negative 2. Okay, I could also have used the slope formula, 4 minus negative 2 over 0 minus 3. 6 over negative 3 is negative 2. Okay, so I could have done the slope that way as well. Okay, then I need the y-intercept, and that's the place where the line crosses the y-axis. So here is my y-axis, and the line crosses it right here. So this is the y-intercept. It is up 4 units. So the y-intercept, b, is 4. So the equation in slope-intercept form is y equals mx plus b, negative 2x plus 4. Okay, we'll try that again. So this time, my slope is positive because the line is rising from left to right. It's rising 2, and it's running 3. And 2 over 3 does not simplify, so my slope is 2/3. The y-intercept, it crosses the y-axis down 1 unit from the origin, so the y-intercept is negative 1. So my equation is y equals 2/3 x minus 1. Okay, we are going to write an equation that passes through these 2 points. The first thing I need to know is the slope. So m equals y minus y, negative 3 minus 1, over x minus x, 4 minus 2. Okay, so I've got negative 4 over 2. So the slope is negative 2. Okay, then I'm going to pick one of these points, whichever one looks easier. This one doesn't have any negative, so I'm going to go with that. And I'm going to call this x1, y1. And I'm going to write this in point slope form. Y minus y1 equals m times x minus x1. Okay, so I've got y minus, and then y1 is 1, equals m, which is negative 2, times x minus x1, which is 2. Okay, so now I'm going to take this point slope form and turn it into slope-intercept. So I'll distribute. Y minus 1 equals negative 2x plus 4. And then I'm going to add 1. And I get y equals negative 2x plus 5. And that is my equation in slope-intercept form. Okay, let's try another one of those. So here are my 2 points. So I get my slope by doing y minus y, 5 minus 2, over x minus x, negative 2, minus 1. Okay, so I've got 3 over negative 3. So my slope is negative 1. Now this time I'm going to use the one with negatives just to show you what happens. So I get x1, y1, and it's really not going to change much. But now I've got y minus y1 is 5 equals m, negative 1, times x minus x1, which is negative 2. Okay, so I've got y minus 5 equals negative 1x, or negative x. And then I've got negative 1 times minus negative 2. Remember, minus negative is plus. So it's really negative 1 times 2, which is negative 2. And then I can add 5. Y equals negative x plus 3. Write an equation of a line passing through this point and parallel to a line with this equation. So in this equation, the slope is 2. I need to write an equation of a line that's parallel. So the slope of a parallel line is 2. Okay, they have the same slope if they're going to be parallel. So here's my x1, y1. I have y minus y1 equals m times x minus x1. So I distribute the 2. Y minus 1 equals 2x, and then this is minus negative, so it's really plus. So I've got 2 times positive 1, which is 2. And then I'll add 1 to both sides. Y equals 2x plus 3. Okay, now we're going to write one perpendicular. So here, the slope is negative 2. Since it's perpendicular, we need a slope of a perpendicular line that will be the opposite reciprocal. So it's going to be positive, and then this is negative 2 over 1, so positive 1 over 2 is going to be my slope. So I have y minus, and here's my x1, y1, y minus 3 equals m, 1/2, times x minus 2. So I'll distribute that 1/2. Y minus 3 equals 1/2 x, and then positive times negative is negative. 1/2 times 2 is 1. And then I'll add 3. Y equals 1/2 x plus 2. Okay, we're going to do another parallel line. Okay, so a parallel line, the slope here is 3. The slope of a parallel line is also 3. Here's x1 and y1. Y minus y1 equals m times x minus x1. Distribute the 3. Y minus 5 equals 3x minus 3. And add 5. Y equals 3x plus 2. How do you know that the lines x equals 4 and y equals 2 are perpendicular lines? Okay, so x equals 4 is going to look like this. It's a dotted line like this. It's a vertical line. Y equals 2 is a horizontal line like this. I've got a horizontal line and a vertical line. Okay, so one is horizontal and one is vertical. Okay, horizontal and vertical lines are perpendicular to each other every single time. Okay, that's all we're going to do, even though it says page 2 of 4. That's all we're going to do for today's lesson. We'll finish up this lesson in tomorrow's video.